Here we want to find the integral from 0 to 1 of the function 1 over the cube root of x. You can see straight away that if we put 0 down here in this function, the function is undefined. So 1 over the cube root of x is discontinuous when x is equal to 0. So in order to calculate this integral and see if it actually exists, we go to the limit and we'll introduce a variable q approaches 0 from the positive side. Because we're going from 0 to 1, that region going from 0 to 1 starts at 0 and goes on the positive direction, on the positive side of 0. And we're going to go between, now instead of from 0 to 1, because we've introduced this q, it'll be between q and 1 of 1 over the cube root of x with respect to x. And that's equal to the limit as q approaches 0 from the positive side between q and 1. Now how can we write this so it's a little bit easy to integrate? 1 over, or the cube root of x. Cube root of x is x to the power of 1/3, and because it's 1 over, it'll be x to the minus 1/3 with respect to x. And the rule with integration is add a power on the power, so the limit as q approaches 0 from the positive side, and when we add a power we get x. Now minus 1/3 plus 1 is to the power of 2/3 all over that power between q and 1. We can simplify that a little bit better, and we can say that's the limit as q approaches 0. Divide by a fraction, we multiply by its reciprocal, and so that'll be 3x to the 2/3 all over 2 between q and 1. Okay, we can then substitute in our values 1 and q. We'll still have to write limit because we're not going to substitute q approaching 0 from the positive side just yet. 0 from the positive side. Okay, now we've got to put in the value 1. So x to the 2 on 3 to the power of 1 will be just equal to 1. So that'll become 3 on 2. Minus, and now we're going to put q, so that'll be 3q to the power of 2 on 3 all over 2. Okay, so as q approaches q approaches 0 from the positive side, this is actually going to approach 0. 0 raised to any power is going to be 0. So that, when we substitute q approaching 0 from the positive side, that whole term there is going to become 0. So we're just left with 3 on 2. So this interval converges. Integral converges to the value of 3 on 2. Okay, now let's have a look at another example. And once again, this function is discontinuous over the interval for integration. So we're going to integrate between -1 and 0, and when x is equal to 0, 1 on 0 is undefined, so the function is discontinuous when x equals 0. So we tackle it a similar type of way. Now because we're going from -1 to 0, we'll use a different letter. P approaches 0. Instead of that 0 there, we're going to put P, but it's going to approach 0 from the negative side because we're going from -1 to 0. So the integral between -1 and P of, now 1 on x cubed is x to the minus 3 dx. Integration rules, we keep writing limits as P approaches 0 from the negative side, and when we integrate that we add a power. So if we add 1 onto that, we'll get x to the minus 2 all over negative 2 between negative 1 and p. The limit as p approaches 0 from the negative side. Probably a better way to write that is x to the minus 2 is 1 over x squared, so that's 1 over negative 2x squared between negative 1 and p is equal to. We can now substitute in our p and negative 1, so that's the limit as p approaches 0 from the negative side of 1 over negative 2p squared minus 1 over negative 2, and when we put x equal to negative 1, x squared is equal to 1, so that'll just become negative 2 on the bottom there. Okay. What we get here is now we can do our substitution for p approaching 0. This term is going to stay the same, so minus minus a half will become a half. And when we make p very close to 0, 0 squared is still going to be equal to 0, and it's negative 2 times 0. So this function here is going to be undefined. So this will be minus 1 over 0, 1 over infinity, 1 over 0, sorry, which is equal to infinity. So p is equal to 0, 1 over 0 approaches infinity. The negative comes from here. Okay, so we've got a half minus infinity. So therefore we say that's going to be a divergent. That's can't be assigned a definite value. So the integral diverges, and two different examples we've got here. Both of them at one of the ends of the intervals the function is discontinuous, and one of them will diverge, and the one we did up the top here, it will converge.